It was unlike anything we've ever seen. Smooth, metallic, and etched with unknown markings and symbols. The object now known as the Buga sphere has become the center of a growing mystery.
This research team has uncovered a remarkable discovery that has the potential to reshape everything we believe about early human civilization. According to their analysis, material extracted from the Buga sphere has been dated to 12,560 years old. The metallic ore, discovered in the Colombian countryside in March 2025, now carries a verified timeline that predates known human metallurgy by nearly 10,000 years. So what does it mean if this object was created by ancient humans, or by something else entirely? In this video, we will examine the evidence and explore the implications of this extraordinary find. The discovery that shouldn't exist. March 2025 began like any ordinary month in the quiet, rural outskirts of Buga, Colombia. Soft morning light spread across rolling fields and scattered farms, while birds called in the distance, marking the start of another peaceful day. Farmers worked their land as usual, unaware that an event was about to occur that would reach far beyond their community and challenge long-standing assumptions about human history. While surveying a freshly plowed field, a farm laborer noticed a brief metallic glimmer reflecting sunlight. At first, it appeared unimportant, perhaps a stone or an old industrial object forgotten over time. But as he moved closer, the shape became unmistakable, a perfectly formed sphere, partially embedded in the red clay soil. Its surface was smooth and polished, completely free of scratches, dents, or tool marks that would normally be expected. The symmetry felt unnatural, almost impossible, yet the object was clearly real and solid. Word spread quickly through the local community, where tales of unusual events were not uncommon. Some believed the sphere was a hoax, deliberately placed to attract attention. Others felt it carried deeper meaning, possibly a remnant from another era or an unknown civilization. Scientists were soon called to investigate, and as images and videos surfaced, curiosity turned into worldwide fascination. Footage showed the sphere being carefully lifted from the earth, its reflective surface bending sunlight into complex patterns across the hands of those holding it. For many viewers, the object was hypnotic, unsettling, and impossible to ignore. Initial scientific examinations revealed details that stunned researchers. The artifact, which became known as the Buga sphere, was roughly the size of a bowling ball and weighed close to 20 pounds. Yet its construction contradicted every known rule of metallurgy. The outer shell was seamless, with no joints, welds, or manufacturing marks of any kind. It appeared to have been created using techniques far beyond the capabilities of any known ancient culture. Inside the hollow interior were 9 to 18 microspheres, suspended and arranged in an exact geometric pattern. Each was identical, perfectly shaped, and precisely positioned, strongly indicating intentional design. Radiocarbon testing of organic material trapped within microscopic fissures on the sphere produced a date of 12,560 years before present, placing the object in the late Pleistocene era. This date came thousands of years before Göbekli Tepe, long before the Egyptian pyramids, and far earlier than the emergence of metallurgy. For historians and archaeologists, this discovery posed a serious challenge to established models of technological development. If confirmed, the Buga sphere represented a level of sophistication that should not have existed at that point in human history. It was not simply ancient. It appeared advanced, raising profound questions about what humans, or perhaps other intelligences, may have achieved long before written records. Eyewitnesses present at the discovery site shared accounts that seemed difficult to explain. Several described the sphere as hovering slightly above the ground before settling, following a subtle zigzag motion rather than dropping straight down under gravity. Observers also noted environmental effects. Plants beneath and around the sphere withered. The soil dried rapidly, and damaged grass failed to grow back. These effects were not superficial. They suggested an interaction between the object and the surrounding electromagnetic or gravitational environment. Soil samples taken from the landing area supported these observations. Scientists recorded significant changes in the dielectric properties of the clay when compared with samples collected only a few meters away. Moisture levels were drastically reduced in patterns consistent with rapid energy extraction. something measurable by modern instruments, but not easily explained by natural processes. Chemical analysis of organic compounds in the soil revealed unusual signatures, indicating that an energetic event had altered the environment. The Buga sphere had not merely rested in the field. It had left behind a measurable and lasting impact. Further examination of the sphere's surface uncovered additional mysteries. High-resolution microscopic imaging revealed faint patterns and irregularities embedded in the metal, resembling symbols or intentional markings. These features were not caused by handling or environmental damage. They were precise, repetitive, and too consistent to be naturally formed. This raised the possibility that the outer shell itself carried encoded information or served a function beyond detecting the internal structure. Some researchers propose that the sphere may have been engineered not only to endure for thousands of years, but also to communicate through geometry and physical design. News of the discovery spread rapidly beyond Colombia. Major media outlets aired reports, and online videos quickly gained millions of views. Debate erupted among scientists, historians, and the public. Some argue the object must be a modern fabrication, while others urge patience and careful testing. Even the most skeptical voices, however, acknowledged that the sphere's precision and construction did not resemble any known object. It was a puzzle that demanded thorough investigation. Material scientists soon joined the effort. Using scanning electron microscopy and energy dispersive spectroscopy, they identified an alloy composed mainly of titanium and aluminum, with trace elements such as scandium and vanadium in ratios rarely found in nature. Isotopic testing revealed patterns similar to those seen in meteorites, yet the overall structure did not match any known extraterrestrial material. Analysis of grain boundaries showed thermal histories inconsistent with forging, casting, or welding. Simply put, no known manufacturing process could explain how the sphere was made. Attention then returned to the internal microspheres. Their precise spatial arrangement suggested they could function as a form of data storage or information encoding. The lattice resembled systems used in advanced computing, where position and geometry carry meaning. Scientists theorized that the configuration itself might represent a message, one capable of preserving knowledge across vast stretches of time. The idea that a 12,000-year-old object could contain encoded information inspired both wonder and unease. To protect the artifact, researchers established strict preservation protocols. Soil, air quality, and electromagnetic conditions were continuously monitored. Passive instruments detected faint rhythmic pulses and subtle thermal cycles coming from within the sphere, suggesting residual or dormant activity. Though outwardly inactive, the object appeared to function in repeating patterns, like a heartbeat frozen in time. Each observation reinforced the idea that the Buga sphere was not merely an ancient object, but a complex and purposeful creation. The implications extended far beyond archaeology. If the sphere represented technology exceeding what humans were believed capable of producing 12 millennia ago, it would force a reassessment of civilization, engineering, and even physical laws. How could such an object exist? Was it created by a forgotten human civilization erased by catastrophe, or by a non-human intelligence altogether? Every possibility stretched the limits of conventional thought. By late March 2025, the sphere had become a global focus of scientific attention. Universities, laboratories, and independent researchers proposed a wide range of tests, from isotopic analysis to electromagnetic monitoring. Artificial intelligence was suggested as a tool to decode the internal lattice. Despite sensational headlines, the prevailing scientific approach emphasized evidence over speculation and careful measurement over assumption. Stored under controlled conditions in Buga, Colombia, the sphere embodied a contradiction. It was unquestionably real, yet seemingly impossible, ancient yet advanced, silent, yet marked by traces of energy and intent. Each new discovery generated more questions than answers. In that space between certainty and mystery, the true importance of the Buga sphere began to emerge. It challenged human understanding, tested curiosity, and reflected the boundaries of what we truly know. Even today, surrounded by advanced instruments and careful observation, the Buga sphere reveals only fragments of its complexity. It inspires fascination and respect, while withholding clear answers. As scientists continue to study it, one central question remains unresolved. who created it, and for what purpose? In the still fields of Buga, under constant scientific scrutiny, the sphere remains at rest, yet its story is only beginning. It stands as a reminder that history and technology are not as straightforward as we often believe. Somewhere within its precise geometry, flawless alloy, and faint energy pulses may lie a message older than civilization itself. A message humanity may not yet be ready to fully understand. The architecture of mystery. The Bugosphere, now secured inside a controlled laboratory in Buga, Colombia, began to reveal layers of complexity that stretched far beyond first impressions. Beneath its immaculate exterior was an internal design so elaborate that every news can only deepen the enigma. Using high-resolution X-ray computed tomography, scientists were able to see inside the object with remarkable clarity. What emerged were 3 concentric metallic shells, each separated by narrow air gaps, surrounding a core of 9 to 18 microspheres. Every microsphere was perfectly shaped and placed at exact distances from the others, forming a lattice of astonishing precision. This was not accidental geometry. It was intentional engineered and guided by an intelligence that conventional human craftsmanship cannot explain. Material scientists quickly turned their attention to the Bugosphere's metallurgy. The alloy consisted mainly of titanium and aluminum, yet also contained trace elements like scandium and vanadium in ratios that do not naturally occur. Isotopic testing revealed irregularities resembling extraterrestrial signatures, although the overall structure lacked the randomness normally found in meteorites. At a microscopic level, the metal told an even stranger story. Grain boundaries showed thermal histories that did not match forging, casting, or welding. There were no seams or joins between the 3 layers. It appeared as if the sphere had formed as a single entity, grown rather than assembled. Yet there was no evidence of additive manufacturing, chemical treatments, or modern fabrication techniques. Every answer uncovered led to even more questions. Inside the hollow core, the placement of the microsphere suggested a purpose far more complex than storage or reinforcement. Researchers identified repeating intervals, mirrored alignments, and clusters positioned along axes that hinted at mathematical intent. Some microspheres follow proportions similar to the Fibonacci sequence, while others align with prime number intervals. Early computational models proposed that information could be encoded through spatial positioning, effectively creating a 3-dimensional memory system embedded within metal. The idea that an object over 12,000 years old might function as an archive blurred the boundary between artifact and data repository. Pattern analysis soon became a priority. Research teams suggested using AI-driven neural networks to study the internal lattice in detail. By mapping each microsphere's position, algorithms could identify symmetry, redundancy, and clustering, classic indicators of intentional design. Preliminary simulations showed configurations that were statistically improbable if formed by chance. Each microsphere appeared to function like a node, potentially capable of holding binary or even quantum information. In this sense, the Bugosphere could be viewed as a cosmic storage device, preserving knowledge across millennia, waiting for a mind capable of reading it. The structure also raised questions beyond information storage, extending into energy and movement. The internal geometry resembled a compact energy network, with nodes positioned as if to channel or regulate forces. Some scientists theorized that this configuration could enable controlled manipulation of electromagnetic or gravitational fields. Such a system might explain reports of the sphere's zigzag motion during descent. If accurate, it would represent a form of propulsion without engines or thrust, a technology humanity has yet to master, but one that exists within theoretical physics. Laboratory testing soon confirmed additional anomalies. Passive electromagnetic sensors detected faint, rhythmic pulses emerging from specific internal points. These signals were extremely weak but consistent over time. Near-field scans revealed localized areas of stronger emissions, implying that the microspheres were active rather than inert. Thermal monitoring over multiple days showed repeating heat cycles that did not match environmental changes. Natural systems rarely operate with such regularity. Machines do, even in a dormant state. The sphere seemed to exhibit a heartbeat, a steady rhythm that resisted simple explanation. For materials science, the implications were extraordinary. creating a seamless alloy with embedded microstructures and unusual isotopic signatures, could redefine metallurgy. The grain pattern suggested rapid cooling processes that eliminated stress fractures while preserving strength for thousands of years. No modern facility can reproduce such results. The method of construction remained unknown, but its outcomes were undeniable. Flawless surfaces, resilient layered shells, and internal components aligned with mathematical precision. Some researchers began exploring the possibility that the sphere carried a deliberate message. By modeling the microspheres as nodes within a graph theoretical framework, they explored potential communication systems based on geometry rather than language. Repetition, symmetry, and numerical ratios pointed toward intentional signaling. If the sphere was meant to communicate, it did so through mathematics and structure, universal languages capable of transcending culture and time. To investigate these ideas, the laboratory established a rigorous, multi-stage verification process. First came detailed material analysis, using SEM and EDS to catalog every element, even in trace amounts. Next was isotopic fingerprinting to assess whether the metals originated on Earth or beyond it. This was followed by microstructural analysis to understand how the object was formed. Electromagnetic and thermal monitoring searched for residual activity, while AI-assisted lattice mapping attempted to decode any embedded spatial information. Each stage emphasized repeatability, transparency, and measurable results, creating a bridge from speculation to evidence. Preservation of the artifact was central to this approach. Non-destructive methods such as optical microscopy, X-ray tomography, infrared spectroscopy, and ultrasound imaging were prioritized. Only microscopic samples were extracted for testing, ensuring the sphere itself remained intact. This balance between investigation and conservation acknowledged that the Buga sphere was both the subject of study and the keeper of its own secrets. Public fascination inevitably fueled controversy. Media outlets reported claims that the sphere reacted to sound, changed weight, or contained filament-like structures linking the microspheres. None of these assertions were verified. Scientists remained disciplined, allowing only observable and repeatable data to inform conclusions. While the sphere captured the world's imagination, the laboratory remained grounded in evidence, documenting only what could be reliably measured. As analysis continued, the Buga sphere increasingly challenged accepted beliefs. Its internal geometry suggested intelligence beyond known human capability. Its materials resisted classification. Its energy signatures implied dormant potential. The object was not just an ancient curiosity. It was a statement of intent, precision, and possibly purpose. Every layer and pulse pointed toward design, hinting at a creator still hidden from history. At its heart, the Buga sphere forced humanity to reconsider its past. If humans created it, then ancient civilizations were far more advanced than recorded history admits. If it was non-human, then it implied observation or intervention by another intelligence capable of planning across millennia. Either possibility demanded an expanded view of technology, intelligence, and the timeline of civilization itself. The sphere also raised profound questions about time and legacy. An artifact built to endure over 12,000 years suggested a different way of communicating across ages. Languages fade, cultures collapse, and records vanish. Geometry and structure endure. In its flawless alloy and precise lattice, the Buga sphere carried a message that resisted decay, a reminder that knowledge can be preserved beyond memory. As scientists continued to scan and analyze, the laboratory became a place of quiet expectation. Every reading carried the promise of discovery. Every anomaly hinted at a deeper story. The Buga sphere had evolved from a curiosity into a challenge, then into a full-scale enigma. It was no longer just an object recovered from the soil, but questions suspended between past and future, waiting to be answered. And so, in Buga, Colombia, the investigation pressed on. The sphere remained still yet active, silent yet complex, guarding its secrets within layered architecture. It stood ready to reshape our understanding of materials, mathematics, and perhaps even the origins of intelligence itself. It appeared without warning, yet carried within echoes of history, technology, and an invitation to push beyond the limits of what humanity believes it knows. Flight, energy, and signs of life. Beyond its flawless shape and mysterious construction, the Bugosphere revealed an even more astonishing trait: the way it interacted with the physical world. Witnesses at the discovery site in Buga, Colombia, consistently reported that the sphere did not simply fall from the sky. Instead, it descended in a controlled, zigzagging motion, as if guided by an unseen intelligence. A straight descent would align with gravity alone, but this wavering trajectory suggested active stabilization, directional control, or even inertial manipulation, concepts that remain beyond modern human engineering. For scientists, these accounts hinted that the sphere was not just an ancient object of advanced metallurgy, but potentially a functional device, capable of manipulating forces that challenge current scientific understanding. Researchers returned to the landing site, equipped with precision instruments. The withered vegetation, scorched earth, and dried clay were not random effects of impact. Soil samples revealed a significant reduction in bound water content compared to nearby control areas only meters away. The dielectric properties of the clay had measurably changed, consistent with an intense, localized energy discharge. These alterations indicated that the sphere may have released electromagnetic or electrogravitic energy, stripping moisture from the soil and affecting surrounding plant life. This was not speculation. Laboratory spectroscopy confirmed abnormal hydration patterns. Such effects do not occur naturally without an active energy source. Something had deliberately altered the environment. The idea of electrogravitics, using electromagnetic fields to influence gravity and matter, has long existed only in theory. Yet the evidence suggested practical application. If the Bugosphere employed such mechanisms, the implications for propulsion and energy were extraordinary. Controlled flight without engines, manipulation of local fields, and the preservation of fragile internal microspheres for thousands of years all pointed toward an advanced mastery of energy far beyond current human capabilities. To investigate further, scientists implemented continuous thermal and electromagnetic monitoring. Passive sensors detected faint pulses at ultra-low frequencies originating from within the microspheres. These pulses were rhythmic and consistent, characteristic of machinery, rather than random environmental interference. Near-field scans identified concentrated zones of electromagnetic activity, aligning closely with the internal lattice of microspheres. Thermal imaging conducted over several days revealed cyclical heat variations unrelated to ambient temperature changes. Even while appearing inactive, the Bugosphere seemed to function on a schedule, a quiet heartbeat encoded in energy patterns, silently confirming operational complexity. Some researchers propose that the microspheres acted as energy nodes, distributing, storing, or regulating power throughout the structure. Under this model, the sphere was not inert metal, but a compact, integrated system capable of advanced energy control. The zigzag descent witnessed in Buga could be a direct result of this internal network. If the microspheres functioned collectively, they could enable precise movement and stabilization, producing flight behavior that defied classical mechanics. This hypothesis was supported by every recorded energy signature and thermal cycle, each aligning with the concept of coordinated internal activity. Further clues emerged from microscopic examination of the outer shell. Certain regions showed subtle microerosion and surface features consistent with controlled friction or energy interaction during movement. These markings were directional, with leading edges experiencing different forces than trailing areas. High-resolution surface scans, combined with AI-assisted simulations, allowed researchers to reconstruct possible flight paths. The results closely matched eyewitness descriptions: a controlled, intelligent descent that left measurable environmental effects. Taken together, the sphere geometry, material composition, and energy behavior suggested a level of design that surpassed modern engineering. If validated, the Bugosphere represented an entirely new category of artifact: part structural masterpiece, part data archive, and part functional energy system. It was not simply ancient. It was technologically sophisticated, a preserved snapshot of knowledge from a forgotten era. Energy-related questions extended beyond flight alone. The spatial arrangement of internal nodes implied long-term energy storage networks, potentially capable of sustaining autonomous processes for millennia. Thermal and electromagnetic readings hinted that the sphere was not completely dormant. Certain systems appeared capable of responding subtly to external conditions or monitoring equipment. It was as if the object, silent for 12,000 years, still retained a faint pulse of activity, waiting for the right moment or observer. Researchers also explored whether residual energy patterns carried encoded signals. Electromagnetic scans revealed structured emissions occurring at regular intervals, while thermal cycles follow consistent rhythms over days. If intentional, these patterns suggested a design that anticipated future detection, a device engineered to communicate across deep time. The Buga began to appear not only as an object, but as both message and messenger, transmitting meaning through energy, geometry, and matter, adding to complexity. The surrounding landscape preserved its own record of interaction. Stressed vegetation, altered soil minerals, and localized electromagnetic shifts provided external data that could be compared with laboratory findings. By combining environmental forensics with internal monitoring, scientists increasingly viewed the Buga as a dynamic system rather than a static artifact. This reclassification elevated it from archaeological curiosity to an active phenomenon with reproducible physical effects. The implications for human knowledge were profound. Functional energy manipulation and combustion-free flight suggested propulsion systems once thought impossible. Such technology could transform aerospace science, energy storage, and space exploration. Yet the object's age, more than 12,000 years, forced an unsettling question. If humans did not create it, who did? Was it the legacy of a lost civilization erased by catastrophe, or the product of a non-human intelligence capable of planning across vast stretches of time? The sphere's potential role as a data archive deepened the mystery. The microsphere's precise lattice could encode three-dimensional information in ways comparable to advanced data storage or quantum systems. If supported by internal energy networks, the Buga was both machine and time capsule. Every node, pulse, and fluctuation represented a possible fragment of ancient knowledge, encrypted in metal and energy. Decoding it would require fusion of material science, computational modeling, and electromagnetic research, a challenge equal to the artifact itself. In Buga, the sphere continued to command attention. Local scientists maintained round-the-clock observation, while international teams collaborated through real-time data sharing. Every thermal shift, electromagnetic pulse, and subtle anomaly was documented. The Buga had evolved from curiosity to challenge to living enigma, embodying intelligence, endurance, and restraint. It inspired awe and caution alike, forcing reflection on humanity's place in a universe where intelligence may take forms we barely recognize. Yet despite constant monitoring, the sphere remained silent. No clear signals emerged, no obvious responses were triggered by human intervention. Its energy pulses were faint, its thermal rhythms cryptic. Whether by design or coincidence, the Buga revealed only fragments of its nature. This restraint elevated it beyond a technological artifact, transforming it into a symbol of mystery, a bridge between known science and the unknown. At its core, the sphere's flight and energy behavior reshaped how researchers approached it. Studying material or geometry alone was no longer sufficient. The Buga demanded holistic analysis, integrating structure, energy, spatial arrangement, and environmental impact. Only by viewing it as a unified system could its secrets begin to surface. In that synthesis, the sphere emerged as a singular construct, a convergence of engineering, physics, and possibly intentional communication, preserved across 12 millennia. The Buga story, therefore, was no longer static. It became an unfolding scientific journey. From its recovery in Colombian soil to microscopic inspection, from lattice mapping to energy monitoring. Every phase challenged assumptions and expanded the boundaries of possibility. The sphere stood as evidence of endurance, intelligence, and the unanswered questions hidden beneath the surface of history. Resting quietly in Buga, Colombia, the sphere carried more than energy or data. It carried a question that echoed across time. What defines intelligence, and how does it choose to leave a trace? As research continued, every pulse and thermal shift served as a reminder that the Buga was not merely an object to study, but a silent counterpart in humanity's ongoing search for understanding. History, myth, and the open horizon. The Buga sphere did not appear in a historical vacuum. Its discovery in Buga, Colombia, echoed deeply through layers of human history, mythology, and ancient storytelling. Across civilizations, legends of vanished cultures, advanced knowledge, and mysterious objects have survived for thousands of years. The sphere seemed to exist precisely at the intersection of myth and reality, a physical reminder that humanity's understanding of its own past remains incomplete. If the associated radiocarbon date of 12,560 years is accurate, the artifact predates known civilizations, ancient pyramids, and even Göbekli Tepe itself, directly challenging the traditional, linear timeline of technological development. Some scholars began drawing parallels with legends of lost lands, such as Mu, a mythical continent believed to have existed in the Pacific and described as home to highly advanced societies. While mainstream science classifies these stories as legend, geological research does confirm the existence of submerged land masses and microcontinents beneath the oceans. This raises an unsettling question. Could the Buga sphere be a remnant of a forgotten era? Perhaps it functioned as a tool, a record, or even a message left behind by beings, human or otherwise, who possess remarkable engineering capabilities long before written history. Its existence forces a reevaluation of possibility, merging archaeology, mythology, and materials science into a single, extraordinary narrative. Yet the Buga sphere's most profound significance may lie not solely in its origin, but in the approach it demands from those who study it. Careful, open-minded science, grounded in measurable evidence, pattern analysis, isotopic testing, energy monitoring, and AI-assisted decoding has become essential. Every microsphere, every energy pulse, every subtle thermal variation represents a fragment of a larger story, one written not in language, but in geometry, energy, and matter. The sphere challenges humanity to confront a deeper question: how intelligence expresses itself, how it survives time, and how it chooses to communicate across vast epochs. The sphere's quiet persistence mirrors humanity's enduring pursuit of knowledge. Civilizations collapse, monuments erode, and written records fade, yet the Buga sphere remains precise and resilient. It stands as proof that information and design can outlast cultures, preserved not through symbols or texts, but through physical structure, energy, and precision. For researchers, the object is both an intellectual challenge and a source of inspiration, urging a broader definition of intelligence, technology, and historical continuity. As research continues in Colombia, global attention remains fixed on the unfolding investigation. The Buga sphere is no longer viewed as merely a scientific curiosity or archaeological anomaly. It has become a bridge between established knowledge and unexplored understanding. Its unanswered questions speak of intelligence stretching across time, civilizations possibly erased from memory, and the durability of knowledge itself. Humanity now stands at the threshold of a deeper historical horizon, glimpsing a past that may be far older and more complex than previously imagined. Silent within its laboratory setting, the sphere poses a question that may guide inquiry for generations to come. What traces of intelligence still lie hidden in history, and how will we recognize them when they finally emerge?